Section 1.5, so what we're going to be taking a look at today. We're going to take a look at variables and expressions. A little bit of vocab first. A variable is a symbol, usually a letter, used to represent a value that is variable, as in it changes. It's not always constant, it's not always the same, fluctuates in some way. We like to use X's and Y's. Not really sure exactly why that convention specifically, but we tend to use those a lot. But there are other variables you see used as well, like if you're talking about area of a triangle, you see the letter A used for area. You see the letters B and H used, B for base and H for height. So sometimes we use letters that represent the quantities, sort of first initial of the word. You also will see sometimes variables that are like Greek letters. So if you've taken trig or anything, you might have seen the Greek letter theta used for things. So it isn't always even just English letters that you'll see used for variables, but it typically is a letter of some sort. The word evaluating means letting a variable equal a specific value. We tend to have this habit of always saying solve, when a lot of times we actually mean evaluate. So the only things we solve are equations, right? You have something on this side, it equals something on this side. That's an equation, that's solving. But when we're plugging a number in for something and we're simplifying down the result, that's evaluating. So these are a couple of examples of evaluation. So if we're going to evaluate this expressions for 1 and 2, we have two, in this case on number 1, values given for two variables listed in my expression. So this is an expression, not an equation, because it doesn't have an equal sign. And we actually can evaluate it for the variables t equals to 2 and k equal to negative 3. So we would take 4 times t is equal to 2 minus, and then k is negative 3, so we need to do minus that negative 3. We saw that back in section 1.2 when we were looking at integers. So we would multiply before we do any addition and subtraction. So what is 4 times 2? 8. And then what happens when we have that minus a negative? Yep, that's addition, and then 8 plus 3 would be 11. Okay, we didn't solve anything, we evaluated. Sometimes we have the same variable listed multiple times and maybe sometimes in different ways in a particular problem, and that happens on number 2. On number 2, it says that the a value that I'm given is equal to negative 4. Be careful to put the value you're plugging in, right, that you're evaluating it for, in parentheses. I'll explain why in just a second. We're just going to put that in there for the moment. Right here, when I have negative 4, I need to remember that the negative and the 4 are both squared. If you leave the parentheses off and you try to shorthand this like on your calculator and you just put negative 4 squared, no parentheses or anything, your calculator is going to spit back out at you that it's negative 16. Because it's not going to know that the negative is also being squared. So that parentheses around the negative 4 tells you both the negative and the 4 are being squared. So we really need that parentheses there. We'll talk about order of operations in a later lesson. We don't use it a whole lot here, but we do need to do the exponent part first. So the negative 4 squared would be where we would start. And what is negative 4 squared? 16, and it is positive. And then I have, well, I'll just do it all in one step in a second here. The same left. And then we'll move from left to right and we'll do all of our multiplication. So what is 3 times 16? Not 31, 48, yep, it's 48. I have negative 2 times negative 4. Yep, positive 8, right? Yep, and then I have the positive 4. So I have 48 plus 4, 48 plus 8 plus 4. 60 what? 60 even? Yes. And we just move from left to right doing our addition or subtraction if there were addition or subtraction listed. Now, I already said this. I guess I was jumping the gun to emphasize the point since I was using them. But expressions and equations aren't the same thing. So expressions are mathematical statements using numbers, variables, and operations. But equations are a statement of equality between two expressions. So we would have some sort of an expression on the left, some sort of an expression on the right, and then there's an equal sign between. That's what makes it be an equation. And I mentioned this word solving, not being the same thing as evaluating either. Solving means we algebraically manipulate an equation in order to isolate a single variable on one side. So in other words, at the end of some kind of a solving process, it's going to say whatever variable it is you're working with, x equals, y equals, k equals, a equals, whatever, on one side, and then it's going to have something else on the other side. Maybe it's numbers, maybe it's still an expression, but you've isolated the variable you're solving for. So on examples 3 and 4, what we're going to take a look at is that very idea of solving. So 3 and 4 are in fact both equations. How do I know? Yeah, they have equal signs. The equal signs tells me they're equations. So we're trying to isolate whatever variable it says in the directions. On this one it says z. Okay? So we need to get the z alone. And there's often more than one way to do that, even more than one correct way to do that when we're working with an equation. Some people really like to keep whatever that variable is on a specific location, like they don't want to move it ever. So if we did not want to move the z on this one, we would actually need to move the x and the y. So since that x is a positive x, we'll subtract the x. And since the y is a negative y, we're going to add a y. And we're doing that so that when these x and negative x add, they add to 0. Negative y and y add, they add to 0. I'm not quite finished, but I at least have no other variables on the same side as z. When I'm doing z's, I tend to put a little line through the middle of them so they don't end up looking like 2's. So depending on your handwriting, how clear it is, you might want to consider that too. On the right-hand side, I have 7 minus x and plus y. Now, this does not say z equals, but it's really close. What would I have to do to make this say z equals instead of negative z equals? So flip the sides. I think there might be an easier way to do it and accomplish the same goal. What's that? Okay, but I can't just take the negative away from the z. What would I have to do? We want it to become a positive. What's that?
Would you square it?
Okay, all right. You guys are full of all sorts of interesting ideas. What do you have from the back? Okay, there we go. So the words I'm looking for are either to multiply or divide. So we're going to multiply or divide by a negative 1. Okay, so some of you may be thinking those sort of same things, but not using the same vocabulary that I am. If we divide by a negative 1, we would in fact change all the signs, which a lot of you were talking about. We want the signs to change. You could also multiply by a negative 1. It also changes all the signs. So whatever was negative is now positive, and whatever was positive is now negative. So I have z equals negative 7 plus x minus y. Okay, so let me show you one additional way to do this problem that might be not necessarily easier, but maybe more intuitive for some of you, more natural. A lot of people simply like to move everything away from the variable that they want it to be. But some people like to make their variables what they want them to be first. For example, that's negative z right now. Are you with me? I don't really want it to be negative z, not at the very end. At the very end, I want it to say z equals. So instead of moving the x and the y, I could move the z. Now, I'm not done in one step here, but I wasn't done in one step on the last part when I did it the other way either. The benefit to this is z is now positive by moving it instead of by switching signs later. Of course, I need z alone, so I need to move my 7 as well. So here now the z is equal to x minus y minus 7. And I know the order is different than when I did it the other way, but do you see that all the pieces are still there with the same signs. They are. So those are two different ways of thinking about it. There may be other options of how to think about it as well that would yield the right answer. But these are two different options. And it doesn't matter to me which one you would use. Okay, let me make this a little bit smaller because it's actually encroaching on my space on the lower part. Okay. Number 4, do you guys recognize that equation? I kind of mentioned it earlier. Yeah, Cole?
Is the area of a triangle.
Area of a triangle. I heard a couple of you saying it. Yeah, it's area of a triangle. That's right. If you didn't recognize it, it's not a big deal. But it is the area of a triangle formula. It wants us on this one to solve for h. And the h is right here. Okay? So I don't have to worry about a sign issue like the last one had. But I do need to somehow move or shift a 1/2 and a b. I'd like to deal with them separately for the moment because I think it's easier to see what happens with them a little bit. Let's just deal with the 1/2 right now. So how would I get the 1/2 to shift to the other side of the equation? There's two different ways to do it. How is the 1/2 connected to the b and the h right now? With multiplication, right? 1/2 is being multiplied by b and h. So what's the opposite of multiplication? Division. So one option is that I could divide by 1/2. It doesn't leave things looking very pretty, right? If I divide by 1/2, now I have a fraction inside of a fraction. That's not real lovely to look at. There is another option that I think is a lot cleaner, or at least it cleans things up as you work. So instead of dividing by 1/2, what could I do? Multiply by 2 over 1. Yeah. So I could multiply by the reciprocal, whatever the fraction was. In this case, it was 2 over 1. So 2 over 1 times a would just be 2a. And then I have my b and my h left on the right-hand side. Does that make sense to everyone? Division is the same as multiplying by reciprocals. We talked about that in the last section, and we did in 1-4. So, still trying to get h alone. How do I get rid of the b? That one's going to be division. B and h are connected with multiplication. So the inverse of multiplication is division. So we would divide by b. So 2a over b equals h. Is the red okay when I write with red? You guys see it all right? Okay. Sometimes further back my colors look a little harder to read. So if that ever does happen, let me know. All right, any questions on either of those two? All right. So, okay, great. We can move things around. We can shift them left and right. We can multiply. We can divide. We can add. We can subtract. But why? Why do we have or need expressions or equations involving variables? What in the world is the purpose? Well, there's actually a really good purpose. What this does, mathematically speaking for us in real life, is that equations and expressions allow us to take complex real-world situations and give them some kind of an order or clarity using the structure of mathematics. They allow us to find solutions in an orderly way. So it's all about structure and order. We've only had 4 classes together. This is number 5, and some of you've missed in different points. But I hope at this point you can at least know about me that I'm a really organized person. So structure and order of mathematics, it just really appeals to my inner, my heart. I want things organized. But I know not all of you feel like that, and that's okay too. I have children in my home who do not feel like that. They're like, seriously, got to clean my room again? Yes, you do. Right? So it's the structure and the order, but the reason that we want it in this case is because it allows us to find logical solutions for what's going on. when I was in my very first teaching assignment, I had a student come up to me with a real world problem. And we talked about it, not with equations specifically and so forth, but her real world problem was that she was going to go rent a house with some friends. But in the house, there were 2 bedrooms, but one of them was much bigger than the other one. There were only 2 bathrooms, and there were 3 people renting it, and there was a garage space for 1 person. And they were trying to figure out what made the most sense in order to divvy up rent. Because to her, it did not make sense that they would all pay the same amount of rent, because in some cases, one person got a garage space and the other ones didn't. Somebody was getting their own room, others weren't. How are they going to share bathrooms that was going to make that make sense? And we talked about the fact that that's a mathematics problem. She may not specifically write down equations for it, but she's going to think about it in an organized, structured way as to what places more value and what actually yields the need or the desire for someone paying more rent to have more of some kind of a luxury in that home. So that's what this kind of stuff does for us. We are going to look our last part of this assignment at actually taking some of those language things that we use all the time and transferring them into mathematical operations or expressions specifically. So we're going to convert language into the structure of mathematics. All right, so here's our first one. Junior has 6 brothers. Y of them went to church. Write an expression for the number who skipped. So if he has 6 brothers and Y of them went to church, how many of them didn't? What would you have to do? Somebody be loud. I can hardly hear you guys this morning. Help me out. Somebody's saying subtract. Yeah? Does subtract make sense? I agree. If you aren't sure if that Y throws you for a loop, just pretend for a moment it's a number, all right? Let's say that Y is 2. He has 6 brothers, 2 of them went to church. What would I have to do with the 6 and the 2 to find out how many didn't go to church? I'd subtract them. So when you're in doubt because of the variable, change it to a number and see if that leads you to what you should be doing in a concrete sense with concrete numbers instead of variables. It is subtraction, you're right. So I would simply be writing down 6 minus Y. I have 6 brothers, Y of them went to church, so 6 minus Y of them didn't. Okay, a few others. Some phrases that we see very commonly. So it says translate each of the following into algebraic expressions. So what do you suppose the phrase less than means when we say for less than K? We only have 4 basic operations: addition, subtraction, multiplication, and division. What would less than mean? It means subtraction. You have to be really careful, though, because some of you have probably already written down 4 minus K on your paper, and it isn't 4 minus K. It's K minus 4. And again, this is one of those cases where if you changed it into numbers, you probably would end up in the right place. So let's say that it said 4 less than 18. Well, what would I need to do? Well, I'd need to do 18 minus 4, right? So make sure you have the order of the subtraction correctly. Subtraction makes us feel a little funny because the order of the subtraction in mathematics doesn't look like it in English, right? I switched it from the English phrasing. Product. What's the word product mean? Means multiplication, absolutely. So if we want the product of x and 5, what would that look like? 5x. And it really doesn't matter the order. We tend to put the numbers in front of the variables, but if you wrote down x times 5, it would be right. The product of 5 and x. More is going on in number C, letter C. It says 14 more than, so let's just do this one piece at a time. More than, what operation does that mean? That's addition. And then it says twice a number. What is twice a number going to tell you to do? Not squared, but you're really close. 2x. You're going to double it, so it's going to be multiplication. Yeah. So twice a number would be 2x. We don't know what the number is, so we'll call it the number x. So it says twice a number, so we'll do 2x. On most of your homework problems, it actually tells you what to let your variable be. So you'll just use whatever variable they give you, okay? So this says 14 more than twice the number. So if I put all of that together, what would it look like? You can do 2x plus 14. On this one, it would even be okay to do 14 plus 2x. Why can I write it, good grief, why can I write it in that order here, but on part A, I had to be really careful which way I wrote it? Yep, but why? Do you know why? Because it's positive. It's because it's addition specifically. So addition has this property that says that the order in which I do it doesn't matter. We'll talk more about some properties here in a couple days. I think maybe actually it is on Wednesday or Thursday. The order of addition doesn't matter, but the order of subtraction really does, right? It does. It matters if you do things in the wrong order for subtraction, but for addition it doesn't matter. So either of these would be acceptable options here because it's addition. Any questions on that? Awesome. I'm going to guess that if you would get started working on your homework, you're probably going to finish it before you leave class today. How cool is that? Awesome, right? All right, so go ahead and get started working on that.